All right, guys, so like I said yesterday, an annuity is either an investment or loan or equal payments are made at the interval. So, yeah. Now, guys, there is a proof for these two formulas if you don't have to know them, so you can look at them if you want to get on the textbook, but I mean, yeah, you really don't have to. Okay, we're just going to jump straight into some examples. And now. Examples, it's now. If you guys maybe just want to write the page number of the example in the textbook, there's quite a lot of writing. I think just to save some time and some effort. And then I'll just pull it up on here. So examples. So I'm just doing the ones that are in the book. So the first one is on page 94. If you have your textbooks here, it would be nice if you could get them out. I know that's not really a thing in this. That will be pretty good. Sorry guys, I'm just propping and you know Okay. I actually don't even have a lot of space here. Okay, so sorry, it is a bit bluish, but it's a color that is in the book. I took a picture and I got it and I inserted it. Okay, guys, so let's see. I hope you guys can read that. They're saying the Timber invests money into a pension fund starting at the end of January 2020. Okay, so important things here is obviously they're saying invests, right? So it's an investment. Now, which formula do we use if it's an investment? Present or future? Future, all right? I see you real quick. All right, future value, so that is the formula that we're going to use. Then they're saying, starting at the end of January 2016. Okay, so the end of the month, the end of January, we paid 1,000 Rand into the fund at the end of every month for 25 years. Okay, so that's our X value, right? Remember now, in these two formulas, we have a variable that we haven't had before, which is X. And X is the value of that payment that the person is making. All right, every month in this case, so X is going to be 1,000 Rand. They're asking us to calculate the total amount of money accumulated into the fund at the end of 2014. Now, luckily, we don't have to calculate what that is. I know sometimes it's difficult. It is for 25 years. All right, from 2016 to 2014. The growth of money in the pension fund is calculated at 12% per annum compounded monthly. Okay, so guys, this is a very straightforward one. We're just going to use the future value formula and we're going to calculate the future value. So we're going to say F is equal to X bracket 1 minus bracket 1 plus I to the power of n, close that square bracket all over I. I'll do that next year. I was teasing you and no one. See what I did? I did the present value one, but just I was too confident. All right, my apologies. 1 plus I to the power of n minus 1. Sorry about that, guys. Let me just make rubbish now. Yes. Okay. So our X value is just that payment, 1,000 bracket 1 plus the interest rate now is 12% monthly, right? So we're just gonna write that as 12 over 1,200. You guys remember that from last year? When it's monthly, then your denominator is 1,200. So the power of it's 25 years now, right? Times 12. On the payment we are going minus 1 to close off with the bracket over that same interest rate. Over 12 years. Because we were going to just pass it in like that. All right. Let's see. I'll do it here. Okay, I am getting an answer of 1,000,000. Nice. 1,878,836 and 63 around. I mean, it's 25 years. The 12%. Okay, easy. Just apply the formula. Type it into the calculator. Fine. This type of question is normally worth 3 marks. I'll give you a mark for using the correct formula. Not really for writing it down, but yeah, there will be 2 marks in this line. So the one will be for the future value formula, the second one will be for subbing in, and then the third mark. So that's an easy 3 marks, right? I'm going to do one where we're going to have to calculate X. That is actually the most common type of question for this topic. So guys, this example is on page 90. Let me just check 95, I think. Yes, page 95. So example 2, you can just write page 95. All right, guys, let's take a look. They're saying a transport company plans to replace a bus in 5 years' time. So that's also in the future, right? They're going to want to have enough money in 5 years' time. The expected cost of the new bus is 900,000 rand. So basically what that means is they are going to need that amount 5 years into the future, right? So the 900,000 is actually going to be the future value of the future. When they're saying money is deposited quarterly, 200, right? Into the fund starting in 3 months' time. Now, guys, this in 3 months' time thing might sound confusing, but if we think, how many months is 1 quarter? 3, hey? Because 12, 1 year is 12 months. And if you divide that by 4, you get 3 months. So when they're saying starting in 3 months' time, that is the same as at the end of the first quarter. Right? Because right now in 3 months' time, we are at the end of the first quarter of the year. So I just want you guys to write just next to this or somewhere, just actually put like in what's this, quotation marks, starting in 3 months' time. That means end of the first quarter. That's something that confuses a lot of people. And remember, we said that the formulas that we have work for when the first payment is made at the end of the first time period, right? That would be repeated. So the end of the first quarter, in this case, is the end of the first time period. Okay, so this is a normal type of scenario. We can just use our formula. You're saying the last deposit is made at the end of 5 years, that's fine. The interest on money paid into the fund is 7.5% compounded quarterly, so that's going to be over 300, right? Calculate the amount of money that they need to deposit quarterly so that the company will have sufficient funds available at the end of 5 years. So they're telling us how much they need. They're giving us the future value here. They're asking us how much must they deposit each quarter. So they're actually asking for the X value. Right, they're asking for that quarterly payment. How much do they have to pay in every quarter? Okay, now guys, since we're solving for X, what I'm going to do is I'm going to write the formula down the other way around, right? Because if we look at the formula, it was S equals X and then all those brackets. But when I'm solving for X, you know, I like having everything X, or the thing that I'm solving for underneath. So I'm just going to write my formula that way around. You say X, and then this. That is right, okay? Just to be in, I'm gonna start myself every time. Over I is equal to S. Guys, do we agree that this is an investment that they're making, right? They're depositing money into an account every 3 months. So it is definitely for that. That is what it is. Now we're going to just sub all of our information in. X obviously is a one that we need to find, so we're going to leave that as X. We're going to say 1 plus the interest is now 7.5 over 400 because it's quarterly to the power of 4 times a year for 5 years. You can write that as 20 straight away if you want to. Minus 1 all over that same interest rate. And that is going to be equal to the future value, which is 900. I want you guys to solve for X on your own now. Think about how you're going to do that. It's fine. Do you guys have an answer? No. No, okay. Oh my God. Okay. Here we go. 37,504.33. So guys, what I did first, and you can obviously do all of this on your calculator. You didn't really have to write this middle step that I have here, but I just got rid of that I first, that denominator. So in my calculator, I said 900,000 multiplied by that. And then whatever you get for that answer, which was 16,875, like I said, you don't have to write this line out. That you then just divide by this entire square bracket. Okay, that whole thing is fine. All right, any questions? Let's do another example. So the next one is on page 100. Okay. Sorry, let's look at this one. This is the last one that we're going to do. Sorry, it does say example 2. Second example over the next 4 minutes, but it's our third example. Okay, plan buying a house at a cost of 850,000 rand. You pay 10% in cash, and the balance is paid using a bank loan. Right, so now we're working with a loan. Right, the two previous questions were on investment. The interest on the loan is 9% compound monthly. Determine the monthly repayment if the loan is repaid over 25 years. So now if it's a loan, what formula do we use for that? The present value formula, right? And guys, the reason for that is the amount that you get for the 850, well, actually that minus the deposit, you get that immediately. Okay, so that is the present value of the loan. With an investment, what happens is you pay money into an account. In the future, you're going to have a certain value, all right, or certain amount of it. So with a loan, it's always present value because the amount that he's getting that amount right now, and then he's paying it over 25 years. All right, so now I want us to find the monthly repayment. So again, they're asking us to calculate X. All right, is that clear? Okay, so now we're going to use the other formula. So this is A. Again, I'm going to write this formula on, or the X on the side. Let me just make sure I'm using the correct formula. Y, sorry. Okay. Yes. Oh. Yeah, I lied. Okay, so this is now 1 minus. Hey, let me just double check. Sorry, I saw something weird on. Yes, 1 minus. Okay. 1 minus bracket 1 plus I to the power of negative n. Remember, this is the one with a negative exponent, which is the first time we've seen that. And that is then equal to the present value. That is fine if you write it the other way around and just store everything in. It doesn't matter. I just like having a lot of solving skills here. Okay, so now we're going to say x, that's what we're solving for, 1 minus bracket 1 plus. The interest rate on this loan, they're telling us, is 9% compounded monthly. So we're going to do 9 over 1200 to the power of negative. Remember that minus negative. What did they say? It's 25 years and it's monthly. Okay, so 25 times 12. Close your bracket equals, sorry, over, I mean, I, which again is 9 over 1200. Now, guys, is our present value 850,000? Is that the amount of the loan? No, it's 850,000 times what do we think? The deposit is 10%. So what is the loan going to be? If the deposit is 10%, the loan is going to be 90%. So let's do that all in one calculation, guys. 850,000 times 90 over 100 or 0.9 if you want. But we could have calculated that first, right? In a separate line. We could have said loan is equal to that times 90%, or even deposit is equal to this times 10%, and then minus it. Right? I'm just trying to show you the shortest possible way to do. Okay, now again, guys, we're going to do exactly the same steps. So we're going to calculate what this is, and then we're going to times it by 9 over 1200. Okay, so I'm going to type that into my calculator. Okay, so I'm getting 573.755. Alright, which you don't have to write down. So if you wanted to write that down, it would be this whole numerator equal to 5737.5. Alright, if you do this calculation times 9 over 1200. Okay. And then you're going to divide it by this whole square bracket. Remember, guys, when you are dividing it by the bracket, keep it in brackets, right? You have to say this whole value divided by bracket 1 minus this. Okay, otherwise it's not going to come out to the right answer. Okay, I am getting this. What else? Yes, that is what I got in the book as well. 6419. Comma 85. Okay, guys, the next one. I'll find that one. Calculate the total amount of money paid on the house by the end of 25 years. So guys, we know that the like cash price or the cost price rather of this house was 850,000, right? But of course, you paid a deposit and then you paid a loan, you paid the loan off, which cost an interest. Right? So in the end, he's going to pay more than 850,000. So they want to know how much in total is Sam actually paying for the house. So what do we think? How are we going to calculate that? Yes, there we go. So we're going to take the amount that he actually paid every month, right? Times by 25 times by 12. Because it was over 25 years, you pay 12 times a year. But then we must still include the deposit as well, guys. We need to add that to it. Okay, so I'm going to write a little formula for you here. Total amount paid is equal to okay, so we're going to work that out. Our payment was 6419.85. And it was over 25 years. You paid that every month. Now, guys, we don't have our deposit amount as a separate value, but can we think what that's going to be? 10% of 850,000. 85,000, hey? So, oh, sorry, not a times, a plus 85,000, or you can just do that calculation here as well, right? 850,000 times, it might be like a 12% or something. It might not be something that you can just work on it quickly. If that's the case, you can just do 850 times the deposit. What's that? Let's see. 649.85. Oh dear, that's a lot. Here we go, 2,010,955. Oh. Okay, guys, we find that one. Now, balance owing. That's just something new. So they're asking us now to calculate the balance owing on the loan at the end of 10 years. So that means now after 10 years, you've been paying this amount, right? You've been paying 6,400 whatever every month for 10 years, sorry. And now they're asking us how much does he actually still owe at the end of 10 years. All right, what we're going to do here, there are two ways of calculating it. All right, I'm going to show you the one that I prefer, and then I think tomorrow I'll show you the other one. So, yeah, let's write here balance owing after 10 years. Okay, now guys, what we're going to do, we are going to pretend, can we listen please? Yeah. No, I'm just going to write the formula, then we're going to sub it and then write the answer. So, show me again how much space? Okay. Thank you, it's over to you. Guys, what we're going to do is we're going to pretend that there are two separate things happening here, even though there's one thing happening. Okay. We're going to pretend that this loan that we're paying back is a loan. Remember in grade 10 and grade 11 when we just use the A equals P bracket 1 plus I to the n. Okay. So we are going to pretend that we have that kind of situation going on. We're going to pretend that you'll see now, that this guy borrowed, it's 850 minus the 85,000. We're going to pretend that he just borrowed the money and he's going to pay it all back after 25 years. Okay, that's not what's happening, but for this calculation, that is what we are going to do. We are basically going to see, after 10 years, if he hadn't made any payments, how much would he owe, right? Or how much would this loan be? Yeah, what would the total on this loan be after 10 years if he hadn't been making any? But then, of course, he has been making payments, right? So to get the balance, we're going to subtract. We're going to subtract the value of the actual payments that he's been making every month. And we're going to see that almost as if it's an investment. Okay, so you'll see now what I mean by that. So we're going to minus the future value of all of the payments that he has been making for 10 years. I'm going to write a little note here. So that key calculation there is going to give us the value of the loan after 10 years. If he hadn't been making any payments, but then we are going to subtract the value of all the payments that he has actually been making, and we're always going to see that as an investment, right? So it's almost like he's taking this loan out, it's a separate thing, but he's also making an investment by paying 6,400 and something around every month. The difference between the two is going to be the amount of the loan. Okay, so this is the future value of all payments made in 10 years. Okay, let's calculate that. This first bit is just like what we did in previous grades. Now, guys, we haven't actually calculated the loan amount, right? So we're going to have to do that now. It was this 850,000 times 90%, right? So I'll just write it here above that calculation quickly. It's 850,000 minus 85,000. So it's 765,000. That is actually the loan amount. Okay, we haven't actually written that down anyway. The guy is not going to pay interest on the deposit, so we have to take that deposit off when we're doing our actual loan calculation. All right, so this is the amount that he's borrowing, 75,000. So this is the amount that's going to go in as our P. All right, as that value there. So we're going to say 765,000 bracket 1 plus 9 over 1,200. The power of 12 times 10, guys, because they've asked us for the balance owing after 10 years. Okay, so we're not using 25, we're using 10 for this calculation. So that is what he would owe after 10 years if he hadn't made any payments. Okay, but now we're going to subtract the value of all the payments that he has actually been making. And we're going to view that almost as if it's an investment. So we use the future value formula. So we're using the 641985 that we calculated in the first question. That is the monthly payment. And then we just fill everything else in as it's given. So the interest was 9% monthly. Now this is to the 12 times 10 again. Minus 1. And that is all over that same interest rate. Okay, now you would have to type that whole thing into the calculator. So I'll just do it quickly. Okay. I am getting 632,955 rand and 53 cents. Guys, if you were Sam, then I think you're upset by this because the loan amount was 765,000. What happened there now? The loan amount, what's going on now? Jesus. This thing just decided he's going to take a little break. Yeah. Okay, so the loan was 765,000. He's been paying 6,400 rand a month for 10 years, and look at what he still owes. That's not nice. Yeah. For the interest, thank you, banks and capitalism and all that stuff. All right, then the last thing, guys. Good. Let me see. They have the same amount in the book. Okay, guys, I want you to do D on your own quickly. I'll move up to the question. They're saying now, calculate the monthly repayments and the total amount paid if the loan is repaid over 20 years instead of 25 years. All right? So you're going to do the same thing that we did for A. Okay, we need to find the monthly repayment. So you're going to calculate your X value, but now instead of 25, you can use 20. And then they want you to get the total amount paid as well, once you calculate your X value. Okay, so you guys are doing D on your own, please. Using the present value formula, all the same values. The only thing that's different is now he's going to pay it back over 20 years instead of 20. Okay, see if you can do that one quickly. Yeah, there is another method which is shorter, but when it gets to deferred payments and decimal payments, it's much more complicated. What do you mean, your final answer? But that same calculation that we did here. No, it will add for that exact calculation. And then just using 20 years instead of 25. Jasper, I'm not sure. Could be. Mm. Mm-hmm. Yeah. On that. Oh, you need to answer that. Yeah, but you have to use the feature. Do you have an answer, guys, or answers? All right, let's take a look. Uh, Are there any questions on that, guys? So that's quite a big difference, hey, in total amount repaid. What was the other one? Was it like 2 million? Yeah, no, 1.7. Okay, guys, I'm going to just give you factors, not that many, because it is, no, I don't know which factors it is. Here's the second practice again. Guys, in the exercises, if you check in the textbook, they say, like they'll say at the top, you may use the formula for the sum of the geometric series or the future value annuity. The reason for that is because this formula, or these two formulas come from sequences and series, like that, how the proof works. But just use these formulas, right? Don't try and use like a geometric series formula for it. Let's see. Exercise 4.3. Number 4, I'm just going to give you one of each, guys, because I'm assuming you guys have been studying with this jar. And then exercise 4.5 is the next one. Number 4 as well. Okay, that's it, guys. You can finish it now. It's, I think my clock is a bit fast. Yeah, we actually are about 14 minutes late. I'm going to fix that clock. Right. Just make sure everyone's looking at down, guys. Didn't catch the answer. No. It's quite
Yeah, that's my job. You can't give it away.
That's what you want to say, so that you can pay it. No problem.
Okay. You get enough.